Hi everyone. In this lesson we're going to be learning about the double angle identities. So those are printed at the top of your foldable. What these identities do is if we know like the sine of theta, these formulas would tell us what the sine of twice that angle measure is. So basically if we knew the sine of 30, this would give us the value of the sine of 60. These are helpful for finding values of angles that aren't our perfect ones, kind of like what we did with our sum and difference identities, how we could find like the sine of 15 by using the difference. So our first example says, or they tell us that the sine is negative 4/5 and cosine is less than 0, and we want to find the tangent of 2 theta. So between these two things, we know where to draw our picture, because when we plug in the tangent of 2 theta, we need to know the tangent, but they only told us the sine. So we have to draw our picture. So since sine is negative and cosine is negative, that means that our triangle is going to be in quadrant 3. So sine is opposite over hypotenuse. And if we do the Pythagorean theorem, we get that adjacent is negative 3. So our formula to find the tangent of 2 theta tells us that we have to do 2 times the tangent of theta divided by 1 minus tangent squared of theta. So from our picture, we can see that tangent is 4/3, so we'll plug that in. So this would equal 2 times 4/3 divided by 1 minus 4/3 squared. So now we just have to do order of operations and we'll be able to figure this out. So this would give us 8/3 in the top. In the bottom we'll square that, so that'd be 16 over 9. So I'm going to get common denominators right away. So since I knew this was going to be a 9, I changed my 1 to 9 over 9, so I'd have common denominators. So we have 8/3 over negative 7/9. So remember, fractions in a fraction, we flip and multiply. So this would give us 8/3 times negative 9 over 7. So I like to simplify before, like see how many times this can go in, but you don't have to do that. You can multiply straight across. If you do, you'd get negative 72 over 21, and we can reduce that by dividing by 3. So that'd be negative 24 over 7. So what this means is that if the tangent is 4/3 in quadrant 3, then double whatever that theta is, the tangent would be negative 24 over 7. Okay, let's try some more examples. So these three are pretty much just like what we did right here. Okay, and they're all using the same given information, like cosine is 3/5 and sine is less than 0. So our picture is going to look the same. So let's try to do the cosine one first, and then you guys can go back and try the other ones. So if we draw a picture, they told us that cosine is positive and sine is negative. So that means we would be in quadrant 4. So cosine is adjacent over hypotenuse, which means our opposite is 4, negative, since we're in quadrant 4. So we're trying to find the cosine of 2 theta this time, and the cosine has 3 formulas that you can choose from. So I generally pick the one based on what I'm given or what I want. So, I mean, really, if we were given cosine, I could use this formula without even drawing the picture. Okay, so it doesn't really matter which one you pick. I'm going to pick this one because that's what we were given cosine, so it just makes it easy to plug in. But we did draw the picture, so we would be able to figure out sine and be able to use either one of the other formulas. So I'm going to use the last one. So the cosine of 2 theta equals 2 times cosine squared minus 1. So again, just do order of operations and you can get those other values. So this would be 2 times 9 over 25 minus 1. So we'll have to get common denominators. So this is 18 over 25 minus 25 over 25, which gives us negative 7 over 25. So that's the cosine of 2 theta. So whatever our angle measure is, if we double it, that would be the value of cosine. So go ahead and pause and try to find the tangent of 2 theta at the top and then the sine of 2 theta at the bottom. Remember, your given information is the same, so you don't need to draw any other pictures. You have everything you need. So go ahead and find those, and when you come back, we'll verify some identities. Okay, so we got that the tangent is 24 over 7, and that the sine is negative 24 over 5. So if you have questions on those, make sure you write them down, and we'll talk about them in class tomorrow. Okay, so let's look at our identities that we have to verify. So our first one says that we have cotangent times sine of 2x equals 1 plus cosine of 2x. So remember, one of our strategies to verify identities is to change everything to cosines and sines. So let's do that on this side and see what we get. And since we have a 2x and that's just a plain x, we need to change this so it would be just a plain x as well. So cotangent is equal to cosine over sine. And then using our double angle identities that we had on the front, we can see that sine of 2x would be equal to 2 sine times cosine. Okay, so now we can simplify some stuff. So if we cross those out, we would have 2 cosine squared. So from here, we need to get that equal to this. So if you take a look at your identity sheet and look at those double angle identities that we learned today, if we play around with some of these, we'll be able to get what we have. Because we have 2 cosine squared, which is like what's right here, and we want that to equal 1 plus cosine 2x. So if I add 1 to the side, then we have everything we need. So this can be substituted for cosine 2x plus 1 if we move that over. Okay, so I'm going to show that work at the bottom just so we can see what we're doing. This is like being able to manipulate our identity. Okay, so our double angle identity for cosine, one version of it says cosine of 2x equals 2 cosine squared x minus 1. So if I play around with this, I'm going to add 1 to the other side to solve for that 2 cosine squared. Oh, I wrote 2, I said 1, I meant 1. So then we'd have 1 plus cosine squared, or cosine 2x equals 2 cosine squared x. So that means I can plug in for this. So 1 plus cosine 2x is equal to 1 plus cosine 2x. So we did it. Remember we talked about how sometimes you have to manipulate the formulas to get them to be what you want, like we did with the Pythagorean identities a bunch. So that's what we had to do here. So let's take a look at our last identity on here. So when I look at this one, I think factoring. We have to the 4th powers, and that's a difference. So it's a difference of perfect squares. So we're going to factor to try to simplify this to get it to equal cosine of 2x. But one way you'd know to do that when you look at it is because they're both to the 4th. So remember your difference of squares said like a squared minus b squared is a minus b times a plus b. So if we take the square root of each of these, we'd have cosine squared and sine squared. So we'd have cosine squared minus sine squared times cosine squared plus sine squared. So what do you think we can do from here? Very good. This right here is 1. So if we change that to 1, we'd have cosine squared minus sine squared times 1. So we really just have cosine squared minus sine squared. And if you look on your identity sheet, that equals cosine of 2x. So cosine of 2x equals the cosine of 2x. And that's it. So if you had any questions, maybe about the factoring or how to do those two that I had you guys do by yourself, make sure you write them down and ask me in class tomorrow. Werner out.